Okay, we back in business. Let's get started. Um, I want to record this video because I need to walk myself through what I just freaking wrote down. This entire piece of code right here that's super weird and confusing. Not really, actually. It's kind of cool and actually not too complex. But yeah, I wrote all of this, no help at all. Or actually some help, I guess an illustration from this course that I've been watching, but he didn't tell me anything, okay? He didn't tell me what to do. He just told me, he walked me through it with these, cool little like node like these drawings and stuff, shit like that kind of. Actually, that was my own. That wasn't his. This is his. So he walked me through it like this. Um, but he didn't have the code there. This is from another function. But yeah, this was like actually my first function that I created on my own, and I kind of worked on it for a while. I was working on it yesterday, and I have this paper in front of me right now. I don't know if you can hear it. Do a little bit of ASMR. Anyways, yeah, I kind of walked myself through it. Let me break down what the function does. Alright, it's called a partition list. I have no idea what that means still, even after the function. I'm guessing it somehow splits up the list, the given list, into two separate groups with an underlying factor, but yeah. Okay, so this function is supposed to, let's see, where's my VS Code? This isn't going to make sense unless you understand code, I guess, but it's essentially supposed to take a given linked list, so something, let's see. So like this would be a linked list, all of these guys right here, um, this circle is called a node. So we got one node right here, one node right here, another node. All of this is a linked list. So given a linked list, when you call the function, it's supposed to take a value that is given by the user. Also, let's say I use the function and I give a value of 5 inside of the parentheses. So that means any node with a value that is less than 5, it's supposed to put it in a separate list, and all of the nodes that are greater than 5 put it in another list. And by the end of the function, it's supposed to bring those two lists together, the two lists together, and have the nodes with a value that are less than 5 on the left side, and then the nodes with a value that are greater than 5 on the right side. And I could draw that right here. So, oops, this is not the brush. So here's my node, right? This is a node. Let's say this has the value of 2. We have another node, say value of 6. Ooh, y'all don't know what's coming. Another node, value of 7. So we got 3 nodes so far. One with the value 2, one with the value 6, and the other one with the value 7. Alright, last node we got, let's just do 4. So if I call this function, right, void partition, I'm just going to shorten it up like this, and I say partition list 5, then that means the function is going to reorder it, and it should reorder it this way. So we should have boom, boom, 6, 7, boom. That's how it should reorder it. That's what it should return, I guess. And yeah, that's essentially what the partition list function does. Here is the code for it. Actually, I'm gonna pull it up in the course because I got it right. Can I make it bigger? There we go. Yeah, so here actually we have our class node. This class pretty much creates a new node, and then here we have our class linked list. This is what creates the linked list. I guess our constructor. This is our constructor. This creates the linked list. Here's our destructor, which deletes the linked list. And we have all of our other functions. And here is our partition list function. So you can see that one of the parameters for the function is, and it's an integer. And that just means, the user is going to enter in like 1, 2, 3, 10, 100, 1,000, whatever. It can't be what do they call them? It can't be a doubles, which is pretty much integer or numbers with decimals, and it can't be anything else. It can only be of the type int. And here is where we get to the logic of our program. All right, this is gonna be kind of a long video, but I'm just gonna say this so I dial this knowledge. I lock this knowledge into my head. Wait, I'm not saying that right. I want to cement this knowledge inside of my head. It's still not making sense, whatever. So, okay, first off, we create a pointer variable. This node dummy1, so this is a pointer variable. Using this creates that pointer variable. And a pointer variable just stores the memory address of something, in this case a node. This new runs the constructor of our class node, which is up here. This is our constructor right here. Actually, it's this right here. So that new operator or call runs it. Why is it so? Okay, it's weird. Alright, back to business. Alright, let's see. I'm just going to shorten it up too. So we have dummy1 this is a pointer variable. It's equal to new node 0. So here's our new node 0 with the value 0 because we put 0 in the parentheses. And dummy1 is equal to it, so we point it. This pretty much just means that D1, dummy1, is storing the same memory address as this node. Then we create another dummy variable called dummy2 or D2, and we also point it at a node with a value of 0. Next, we set prev1 equal. Actually, I'm going to do it like this. Prev1, I'm just going to say P1 is equal to dummy1, which just points P1, a pointer variable, at the memory address which is stored inside of D2. Okay? And then prev2 is, same thing for that. And then runner is going to be equal to head, checker is going to be equal to head. These are still pointer variables. Head is pretty much the first node in the given linked list. So, let's say back to our example, we got 2, we got 4, we got 6, 7. Okay, so here we have R. Here we have C. C stands for checker, R stands for runner. Okay, so checker and runner, these pointer variables, they are going to essentially check whether or not the value of the node is greater than or less than 5, or whatever the given value in which we want the nodes to be less than or greater than 2. But in this case, I'm just going to say 5. So let me say x is going to be equal to 5. Alright, now we can begin the actual code which makes the list. This is just to check to make sure there's a linked list, there's actual nodes in the linked list. So, alright, so we have this while loop, while runner. Runner, this is the same as saying this. Okay, and null pointer just make sure that runner, this pointer variable, doesn't reach the end of the linked list, and when it does, then it's going to exit out of it. So we have an if statement, if runner value. So if runner value is less than x, then all of this code's going to execute. So runner is going to be equal to runner next. So in this case, this is what's going to happen. Since 2 is less than 5, runner is going to be equal to runner next. Checker next is going to be equal to null pointer. So that pretty much takes it away from that linked list. It pretty much separates it from the linked list. And prev1 next, which is up here. Oops. Prev1, where is it? Oh shoot, did I? Oh, I'm an idiot. Sorry. Let me get out. What an idiot. We got prev 1, prev 2. Alright, where were we? Okay, prev 1 next is going to be equal to checker. That pretty much brings checker up there. And then prev 1 is equal to prev 1 next. So that moves this pointer variable to point at this node. And then now we have checker point back to runner, so it can continue doing what it just did. Oops, I took some of that node off with it. And then we pretty much repeat. Again, same thing. 4 is less than 5. Oh my god, I hate this so much. I hate this paint window things. So we do that. We do that. It's less than 5, so it's going to go here. And then prev 1 is going to be equal to prev 1 next. And then checker is going to be equal to runner. Okay, now we have a value that is greater than 5, so it's going to go to this if statement, this else part, because this condition isn't true. So it's going to go here. Same thing for the first few lines of code. Runner is going to be equal to runner next. Checker next is going to be equal to null pointer. Prev 2 next is going to be equal to checker. Then we're going to have prev 2 is equal to, oops, piss off. Prev 2 is going to be equal to prev 2 next. And checker is going to be equal to runner. And then same stuff. So here's where it gets cool. Runner is now equal to null pointer, but we're on the first line of code, right? So we still have to execute these lines of code before the computer goes back up to check if this condition is true. And it's pretty cool. So again, we do this, and this. Boom. So now we've executed these lines of code, and the computer goes back up to this while loop to see if the condition is true. And it's not true. Runner is pointing at null pointer, so it exits out of this loop and goes to these lines of code. Prev 1 next is equal to dummy 2 next, which means prev 1 next. Let's see. Prev 1 next is going to be equal to dummy 2 next, which is pointing right here. And then head is equal to dummy 1 next. So head's going to be equal to here. And that is all of our code. That's it. You can see how this was necessary, creating 2 dummy nodes and dummy pointer variables to assist with connecting the linked list and creating the head. And honestly, I would have never thought about this on my own. I did figure the code out, but the idea of creating 2 dummy nodes was brought to me by the instructor of the course. But it's pretty cool. I'm very proud of this work right here, even though it may be simple or whatever. It wasn't simple for me. That's all I'll say. But yeah, this is this is pretty cool. It's cool stuff. I spent like a day kind of procrastinating, not doing jack, but I eventually did it, and yeah, here we are. It all fails. That suck. So yeah, it's good stuff. More to come. I still have a crap ton of sections left, but I'm up for the challenge.